Okay, apparently you guys think I'm boring, so I will try to make this brief and less monotone because apparently I speak in monotone. This chapter deals with how to gather data using surveys. So here we go. The first big idea is when you do a survey, you really only want to examine part of the whole. We want to know about everyone, and remember, everyone is the population. But this is pretty much impossible and definitely impractical. So usually we just care about a smaller group, which we call the sample. Okay, same thing. I'm going to keep going back to this idea about vegetable soup. You want to know about an entire pot of soup, but you don't have to taste all of it to know whether it's good or not. All you got to do is sample it, and you trust that sample, if it's good, then the soup's going to taste good. Alright, so a survey is usually just designed to ask a sample of the population a series of questions in hopes of learning something about the entire population. That's the whole point of a survey. And I don't know about you, but typically I don't want to participate in real surveys. But since I started teaching this class, I tend to say yes more often now because I know how much of a pain it is. But it's frustrating because a lot of times, like for example, pollsters, people who do polls and all that, how can they claim that their information represents the population when they never asked you? So that's another reason why I like to participate. The other thing I don't understand is when you're watching TV or you're looking at ratings of television shows, they say, had a rating of 4.1, and somehow they know that, 4.1 million viewers, or maybe it's 4.1 thousand viewers out of every 10,000. I don't know. But I don't understand how they know who's watching the television show, because I have bunny ears. So how do they know that I'm watching Marvel Agents of S.H.I.E.L.D., which is an amazing show, but every show that I find amazing, they always tend to cancel because it doesn't get good enough ratings. But they never ask me, which is really frustrating. But I guess that's the idea of sampling. If a sample doesn't represent the population, it's said to be biased. Okay, there's certain sampling methods that will make the responses more biased than others, depending on the question, depending on how they do it. There's just a variety of ways that your surveying technique can bias the results. Whatever the reason is, it's not a good thing. So here's an example of very, very biased results. In 1936, the presidential election was Alf Landon versus FDR. A magazine mailed more than 10 million ballots and got 2.4 million back. This is a very high response rate. This is almost 25% response. Normally, it's not this high. You'd be lucky to get 10% back, usually. I don't ever send anything back unless they send me money to begin with. I opened the mail one time and there was a dollar bill in there, so I took that survey. But then I thought the dollar bill might have anthrax on it, so I was a little sketched. But when they got their results back, they found that Landon was going to win the election, 57% to 43% for FDR. So this is a pretty impressive, swing. But I don't recall a President Landon. Roosevelt won the election 62 to 37, and the magazine went bankrupt, and it was a disaster. So what went wrong? What do you think went wrong? Pause it, think about it. Why do you think this went wrong? Well, clearly the sample did not represent the population. It was biased in some way. And so the question we ask ourselves is, where in the world are you going to get 10 million names in 1936? Anybody? Anybody? Nobody? Okay, well, I'll tell you the answer. The phone book. And what kind of people had phone books? Not phone books. What kind of people had phones in 1936? Rich white people. Okay? So owning a phone was for the rich. The sample, although it was 10 million strong, didn't focus on everybody. So how do modern polls avoid this problem? How do we fix it? Well, that brings us to our second big idea, and that is randomization. Okay, you've got to randomize your sample. If we go back to the soup, if you add salt to the soup and then you sample it, what's going to happen? Well, it's going to taste very salty if you don't stir it. So you got to stir the pot. That way, the amount of salt in the soup is randomized. Okay, same deal with like peas. I'd hate for you to put peas in the soup and they sink to the bottom, and then somebody samples it thinking that there's no peas in the soup. Okay, you got to stir that soup up. You got to randomize it. Emily, stop staring at me. Okay, because you got to protect yourself from peas. So, when you're selecting people to survey, or doing a survey, you've got to select from the population at random. It protects from all the features of the population by making sure that on average the sample looks like the rest of the population. So if you were to take a random sample and a random sample and a random sample and a random sample, on average that random sample should represent the population. Alright, third big idea. Sample size. How large of a sample do you need to represent the entire population? If we go back to soup, if we're cooking soup for your family or cooking soup for an entire banquet, do we need different sized spoons to sample the soup? I mean, do you have to take a whole ladle if you're cooking for a banquet, or will a small spoon still work? And if you don't cook, just so you know, a small spoon will still work. Okay, you don't have to have a certain percentage of the population. It's just how big your sample is. 100 random students at BHS tells you just as much about Blythewood High School as 100 random citizens of the U.S. can tell you about the U.S. Okay, it doesn't really matter that that 100 out of all the Blythewood students, which is 5% of the students, versus 100 out of the United States, and this is not even a percentage. It doesn't matter what the percentages are. It just matters that you get a large enough number. Okay, the key though, and you should know this by now, the sample should not be more than 10% of the population. Alright, so here are the big ideas. Only taste a spoonful. Don't drink all your soup. Make sure you stir your soup before you take a sample of it. And you don't need a bigger spoon for a bigger pot. That is surveying technique in a nutshell. So, since samples don't tell you everything about the population, it just gives you information about the sample, which hopefully tells you about the population, wouldn't it be better just to sample everyone? When you sample everyone, it's called a census. Okay. It doesn't matter if you're sampling all the fish in a lake, which is stupid because it can't be done. It doesn't matter if you're sampling all the candy in a factory, which would be stupid because you gain a lot of weight. If you're sampling everyone or everything, it's called a census. And it definitely would provide the most accurate information. But it's very difficult to do. That's why they only do it every 10 years for the United States. It's expensive to find everybody. It's expensive to go hunt people down and ask them questions. It's expensive when your parents don't fill out the sheet of paper, which is all it is. And so they have to send somebody. Our taxes have to pay for somebody to come to your house and fill out a single sheet of paper. It's pretty stupid. And in case you're wondering, in 2020, you're going to get some mail in your mailbox, and you should fill out this paper. Okay, so in 5 years, please remember this. Okay, well, you'll probably still be in college or grad school or something. But if you're not, okay, please fill out this sheet of paper. It does not take very long. You're basically putting names, birthdays, jobs. Okay, it's very simple. A few people get a long form, and a few random people is really what it is, get a long form, And that's supposed to give us all this other information about the United States. But the true census is only a single sheet of paper, so it's pretty easy. Also, think about this. Does it make sense to do a census of all the Twinkies? Wait, Twinkies is not a good example anymore because Twinkies went out of business. If you were making hot dogs at a hot dog factory and you were the taste tester, would it be a good idea to sample all the hot dogs in the factory? No, that'd be gross, and you'd be fat, and you'd probably die of heart attack or something, and it'd just be awful. And especially if you opened a pack of hot dogs and there was a bite taken out of every hot dog in your pack. That would just not be fun. But they still want to know if the hot dogs taste good, so they have to sample them. But they just don't do a census. That's just ridiculous. Populations don't stand still. By the time you census the group, it's already changed. So especially with a large population like the United States, you can't sample everybody easily and quickly because there's just so many people. So that's a pretty big deal. It's very complex to do. It does take, the bigger the population, the harder it is. And then this thing right here was just something I found on the internet. Obviously this is a video, so you can't click on it. But if you go to the notes, this link might work. I say might because I tried to click on it tonight and it didn't work. So I don't know what the deal is. But what it is it's a picture of the United States where they put one dot for every single person in the United States in 2010, and they put it where they live. So like zoomed out, you can really see population densities. You can really see the United States. It's kind of awesome. But then you can actually zoom in on different parts, and I actually found my dot from 2010. So it's pretty cool. So if you want to check out the notes, that link should work. Alright, so you should remember this from way back when. This is probably August. But when we're dealing with a population, like if I want to know the mean height of all men in the world, that's a parameter. So a population parameter, PP. If I just want to know the mean height of a sample, it's called a statistic, SS, sample statistic. Ideally, when we do a survey, our statistics, like X bar, sigma, all that stuff, tell us about our parameters, which were mu and sigma. Oh, well, I need to read. And then the proportions, that was p hat and p. Alright, so I'm going to give you a variety of examples of different surveying techniques, different samples you can collect, and then we'll talk about some bad ones. So the first one is a simple random sample. You've seen this on some AP questions, SRS. Each person has an equal chance of being selected. And each combination of people has an equal chance of being selected as well. So it is very simple. You give everybody a number, you randomly pick a number, or 5 numbers or whatever, and that's it. That's your sample. The sampling frame is the list of individuals from which, I should say, sample is drawn. So like, for example, if I were to do a sample from the school, I would get the roster of all the students in the school, and that would be my sampling frame. The sampling frame for voting in the United States election is all the voters. To do a simple random sample, it's easy to just number every person. Golly, I can't write any words. And then randomly generate numbers from a computer or a table or whatever. We've been talking about this forever, I feel like. Sampling variability. Each sample is going to be different. So each statistic from the sample will be different. So like if I were to generate a sample from the Blythewood High School students, somebody else were to do it, somebody else were to do it, and we were finding the mean, or just like the GPA. Well, my sample's average GPA is going to be different from another person's, And that's called sampling variability, and it's okay. It's also called sampling error, but it's not an error. All right, technique number 2 is called stratified sampling. When you divide the population into groups, and then you sample from within the groups before the results are combined, that's called a stratified sample. So, for example, I might split into males and females, and then I get 50 randomly selected males and 50 randomly selected females. And then I put them together to get my sample of 100. That's a stratified sample. I can split the school into 4 groups, and then I can get 25, 25, 25, and 25. And these are 25 randomly selected people, put them all together, and that gives me my group of 100. By doing this, it helps to reduce sampling variability. I could even split it into grade and gender, and then get get a randomly selected group from each one. All right, cluster. When you split the population into clusters, which are not the same as strata because clusters have like a variety, like they have a representative population within them. So it's not like you're dividing them by some key feature like males and females, which are very distinct. It'd be like these, splitting into the 4 houses. But instead of getting a few from each house, we're going to randomly pick one of the houses. So, hey, I randomly picked BBD. Okay, and then I'm going to perform a census within that group. Okay, if there was more than 4, I could potentially pick, maybe I could randomly pick 5 of the clusters and sample everyone in the cluster. If I looked at a page in a book and I just randomly pick one page and then I do a sample of just that one page, that page is a cluster. It should pretty much represent a page in the book. And so if I were to, maybe I was looking at the number of times the letter E is used, I don't know. We could take one page, and that'd be a lot easier than doing stratified where I'd, randomly pick a few from each page. It's just easier to pick one cluster and then sample that entire cluster. This is typically practical and affordable. You still have to have randomness, so you have to randomly pick your group, but then you do a census of that group. All right, systematic is super easy to pick out. You're going to see something like survey every 10th person, survey every 25th person, survey every 30th person, survey every 100th person, survey every 3rd person. Anytime you see something like that, that's a systematic sample. To make it random, this is a key. You have to start the survey from a randomly selected individual. So if I'm surveying every 10th person, I'm going to randomly generate a number between 1 and 10. Let's say I get 7. And then I'm going to do person number 7, person number 17, person number 27, person number 37, person number 47. You get the idea. As long as the list is not in order in a way that is based on a response. So like if you're looking for average salary, but then you sort the list by salary, that's not a good thing. Okay? If you're looking for average salary, but you sort the list alphabetically, that's fine. If I'm looking for average GPA and I order the school by GPA, that's not good. But if I order the school alphabetically, that's fine. So anyway, systematic sample is pretty easy to pick out. Multi-stage, you're probably not going to see this on the AP exam, but this is just when you combine a few methods into one. So maybe you split them up into 9th, 10th, 11th, and 12th. And then within each one, you survey every 10th person. So we did stratified by splitting it up, and then we're doing systematic when you survey every 10th person. Okay, so just getting back to a summary of what we talked about. You only need a sample to learn about the population. Make sure it's random, and it's not the size of the. I guess the size of the sample doesn't need to be bigger for a bigger population. Okay, so size doesn't matter. Well, you can't be too. You can be too big, okay, because you have to be less than 10%, and you can be too small. But it doesn't really matter how big the population is. Again, if a sample doesn't represent the population, it's biased. We'll get to that. And then these were the 5 types of samples that we did. Okay, everyone is a census. SRS, everyone has an equal chance of being selected. Stratified, split into similar groups and then do an SRS. Cluster, split into groups and do a census. Systematic, you're looking for every nth person, but make sure you start at a randomly selected person. Okay, sampling frame is where you get your people from. Sampling variability, which is also the same thing as sampling error, is because samples are different. Okay, so let's get to some bad samples. Okay, voluntary response sample. When you just invite people to respond, everybody who does gets surveyed. This leads to a voluntary response bias, and it's completely invalid. Doesn't matter how many people you get. It's just no good. Okay. This is like those internet surveys. Click here to take our survey. Okay, that's voluntary. You don't have to do it. And I know that every sample is voluntary, but this is truly like you only have to do it if you want to go and get the paper, or go and click the link, or go and do this. So why do you think it's invalid? Well, let's put it this way. The complainers are typically the loudest people. Okay? Only people that are truly passionate about the topic are going to voluntarily respond to the survey, whether it's passionate for it or passionate against it. But those are the only people that you're going to get. Okay, so voluntary response, never a good thing. You need to pick out the people that you're going to survey. Don't just say, "Hey, who wants to take my survey?" Because that's going to lead to bias. And that's really how a lot of you did your projects at the beginning of the year. This is how the rest of you did your projects. Convenient sampling. When you just survey people that are convenient. So, hey, let me survey everybody in the classroom. Hey, let me survey this person. He's walking right up to me in the hallway. It doesn't represent the population because it's not random. Okay, you're only getting certain types of people. If I go to Sandhills and I survey people walking around the mall, I'm only getting people who shop at Sandhills. If I'm surveying AP statistics students, I'm only getting y'all's take on it. Okay? And don't tell me you can randomly pick people who walk by you. Okay? That's not random, and that's convenient because you're getting a certain type of person because they're in the same area that you are. So, bad. Convenient sampling. Bad. Undercoverage, this isn't really a sampling technique, but it is a type of bias. When a portion of the population is not sampled, if they're missed, or even if they're just not represented fully, that's called undercoverage. So, like, if I randomly pick 100 students and they all end up being male, then that is undercoverage because I'm missing the female response. If I survey people by calling house phones on a weekday morning, I'm going to miss people. People that have a job. I'm missing people that don't have house phones. I'm missing people that don't have yoga in the morning or Zumba or whatever people are into, CrossFit. Um, you're missing people. Okay, so this is under coverage. You're not getting the entire population. Non-response bias. This is when people don't respond. Okay, nobody's going to get responses from everybody that they survey. It doesn't happen. The problem is if they don't respond to the survey, then potentially, okay, they have different views than the people who do respond to the survey. And I'm not talking about voluntary response here. I'm just talking about you did a systematic sample of Blythewood students. So let's say every 10th student at Blythewood High School, you surveyed. That would give you, okay, every 50th student at Blythewood High School on this list of Blythewood High School students you survey. And you only get back half of the responses. Well, the other half who didn't respond might have different opinions, which is why you should pay people. If you're truly, doing a really good survey, you should pay people to fill it out. Dr. Reed, who teaches down the hall, 522, she got her PhD, and part of getting a PhD is showing that you know how to do research. And she was researching more or less perceptions of African American students in lower level math classes. And she was looking at some schools in Fairfield County and some schools in Richland County. And, she didn't have to, if she asked the Blythewood teachers to fill out the survey, we were going to do that. But the people in Fairfield County didn't know her from the next lady. And so to encourage them to fill it out, she gave them gift cards to do it. So it doesn't really change the results when you pay, because they're still anonymous, I guess you could say, in a sense. But it does give them incentive for filling it out. I'm much more likely to fill out a survey if I'm getting a $5 gift card. I had to watch some students in my class and observe them, and for every survey I filled out, I got $5, and then if I did this big survey at the end about that student, I got $40. And I had, I think, 5 or 6 students in my class that I could do this for. It was easy money. It was free. It did not take that much time. But even with this payment, there were still teachers at Blythewood High School who taught the same kids, who were given the same opportunity, who just didn't take it. So people who don't respond to surveys are going to have, there's potentially a bias there because their voice is not heard. Okay, the opposite of non is not response. So response and non-response, they're not opposites. But a response bias is anything in the survey design that influences the response. Okay? Anything that can influence the response. Like if you walk up and survey someone butt naked, that's going to influence the response. Okay? They're clearly either going to not answer, that's non-response. They're going to answer it very quickly so you'll get away from them, or they'll call the cops and you'll be in jail. So here are a couple things that could influence the response. Do the respondents understand the question? You have to be very clear in what you're asking. Is it a topic where respondents are likely to lie? That's a response bias. If it's not anonymous, then maybe they're more likely to lie. If I were to ask every one of you to tell me about your drug habits and your addictions and your alcohol use and all these other habits that, one, I don't want to know about, so don't tell me. But two, as a teacher, you're not likely to tell me the truth if your name is attached to this. Okay? So, I mean, y'all have got your good images to uphold, and so you're probably going to lie, just so that way you don't get in trouble or, anything like that. And sometimes your wording, just the wording of the question will affect the response. So here's three examples on the next slide, and they're going to kind of tie in with each of these questions. Okay, first one. Does anyone in your family speak a language other than English? Okay, this question can lead to a response bias because you may not understand what I'm asking. Okay, because perhaps you have a little baby and she speaks this gibberish babble. Well, is that a language other than English? I would say so. Ryder doesn't say some words correctly. Does that mean it's another language? Well, it's not English. What he says is not always English. So, depending on how you read the question, you may not exactly understand what the surveyor is saying. Maybe my family speaks Spanish, but then they speak like maybe, Puerto Rican Spanish versus Mexican Spanish, and then they can speak both, and maybe you classify that as two different types of, two different languages other than English. There's just a lot of ambiguity. There we go. See, that's why you have a wife. In this question, so you have to be very clear about what you're trying to ask. Do you have any illegal drugs on you right now? If I were to ask you that question in class, you're probably going to lie to me. Because if you have illegal drugs on you, and you say yes, I will call the drug dogs or the cops or whatever, and they're going to search you and find it. And then you won't get to take the AP test. Your life is ruined. You're in jail for years. And, yeah, not good. So you're going to lie. Or you should lie anyways. But you shouldn't use drugs, so that's a completely separate matter. Don't lie. Don't do drugs. Stay in school. Okay? Third question. Should killing babies be legalized? Well, duh. Everybody's going to say no. If you really meant to ask your question about abortion, okay, then you should make sure the wording of your question doesn't influence the response. Should abortion be legalized? That's asking, in your mind, the same question, but the way that the question is asked clearly is going to influence the results. No one in their right mind is going to say that killing babies should be legalized. Just the same thing as, I think I saw one thing, like, should wiretapping be allowed? Well, most people are going to say no. Okay? They don't want their phones tapped. But if you put like this in the question, like should wiretapping be allowed, for national security purposes or in order to ensure that our nation stays safe, then it's going to change some of the responses. People are more likely to say sure. If it's for national safety, then yeah, I don't mind. So it really, how you word your question, you've got to consider because it's going to influence the results. All right, so that was a whole lot of information. I tried to go through it as quickly as possible, but I do want you to practice. So if you go to the web page, there's going to be a file that allows you to practice. It's just a Google form. It asks you a series of questions, and then you can when you click submit, it will automatically send you back the correct responses in addition to your responses. So give it a shot. If you need to, go back and watch the different types of sampling techniques and the bad sampling techniques as well, and go from there.